right, so we're going to be looking at 8.4 arithmetic series, and it says find the sum of the terms of an arithmetic sequence. Use series to solve real-world problems. So a series is simply the sum of the terms of a sequence. So a series is really just a summation. So an infinite series is when we go from 1 to infinity, and we say a sub 1 plus a sub 2 plus a sub 3 plus, and it just keeps going. We keep adding numbers forever and ever. And then a finite series is when it goes from 1 to n, and we say a sub 1 plus a sub 2 plus a sub 3 plus whatever terms are in between all the way to a sub n. Our focus today is going to be on finite series. So we have an arithmetic series. It's the sum of the terms of an arithmetic sequence. Evaluate each arithmetic series. So all a series is a summation. So we're really just doing what we did in our summation unit, but now we're calling our section. Now we're calling that an arithmetic series. So all an arithmetic series is a summation. So we're going to be adding a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5 plus a sub 6. That's all we do. So the first term would be 2, and if you want me to, 2 times 1 minus 1. This is going to be 2 times 2 minus 1. This would be 2 times 3 minus 1. 2 times 4 minus 1. 2 times 5 minus 1. 2 times 6 minus 1. So 2 minus 1 becomes 1. 4 minus 1 is 3. 6 minus 1 is 5. 8 minus 1 is 7. 10 minus 1 is 9. 12 minus 1 is 11. We add them up and we get our final answer. I'll let you guys go ahead and add those up and get that final answer. Now, part B, notice that part B is different than part A. There are no parentheses around the 2n minus 1. Therefore, this right here is my series, and at the end I'm going to subtract 1. So I'm going to have a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5 plus a sub 6, and then I'm going to subtract 1. On this one, I subtracted 1 for every term because the minus 1 was part of the sequence. Here, I'm only subtracting a 1 at the end. The minus 1 is not part of the sequence. So this is going to be 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6, and then I'll subtract 1. So I have 2 plus 4 plus 6 plus 8 plus 10 plus 12 minus 1. And I'll get my final answer. And you will see that these two are different. They should be 5 apart. This one should be 5 smaller than this one. If not, then you typed it in your calculator incorrectly. This right here is another way of writing this. This means from n equals 1 to 9. That's what that means. So I've got to add up the first 9 terms. 7 plus 11 plus 15 plus 19. Well, I don't have the other terms. I've got to figure out this is plus 4 plus 4 plus 4. If I add 4, I get 23. If If I add 4, I get 27. If I add 4, I get 31. Add 4, I get 35. Add 4, I'm at 39. So I need to add up all of those terms, and I'll get my summation, my S sub 9. So S sub 9 means the same thing as the summation symbol from 1 to 6. It's kind of like a shorthand way of doing it. All right, so now let's come down to this one. This one says add up the first 500 terms, and it's just n. N is the formula for the sequence. So that would be a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 all the way to a sub 500. That's going to be 1 plus 2 plus 3 plus 4 plus all those numbers plus 500. But I've got to add all these numbers here. So am I going to go to my calculator and say 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 and go all the way to 500? It's going to take me a really long time, which means there has to be a shortcut. There has to be a formula for adding all of the elements in an arithmetic series. Okay, now notice again, every series that we've looked at has been arithmetic. The terms here increase by 2. Here my terms increase by 2. Here my terms all increase by 4. They all have a constant difference, so they're all arithmetic. These all increase by 1. So for arithmetic series, we need a formula. So the formula for an arithmetic series, when you're adding up all the terms, where a sub 1 is the first term and the constant difference is d, the formula for this series is, because remember this is a shorthand term of saying from n equals 1 to n, we can just say S sub n. You take n divided by 2, and then in parentheses the first term plus the last term. Now, sometimes we don't know the last term, and therefore we have another formula that we can use, n divided by 2, 2 times the first term plus n minus 1 times the constant difference. So if you don't know what the last term is, you can simply use this formula. Some people choose to just figure out what the last term is so that they can use the first formula. Sometimes it's not worth the work of figuring out the last term, so people simply use this second formula. All right, so let's go ahead and try this formula on the previous one where we were supposed to add up the first 500 terms. So if I'm trying to do that, S sub 500 equals, remember my formula, let's write our formula right here, S sub n equals n divided by 2, and in parentheses the first term and the nth term. So I've got 500 divided by 2. Notice this says 500, this says 500, this says n, this says n. Times the first term is 1, and the last term is 500. So we have S sub 500 equals 250 times 501. So I go ahead and I put that in my calculator, and I will get the sum of the first 500 numbers. Okay, all right. So let's say the reason we even study these series is because they have real life implications, real life problems that we can use these series to solve. Here's an example. A student borrowed $4,000 for college expenses. The loan was to be repaid over a 100-month period with monthly payments as follows: $60, 59.80, 59.60, all the way down to 40.20. Now if you notice, this goes down by 20 cents, this goes down by 20 cents. So the constant difference must be negative 0.20 because we're going down by 40 cents. Just in case we need that. Don't know if we're going to need that. They did give us the first term and the last term. So it seems as if I'm going to be able to use this formula, so I don't need to know my constant difference. But the one thing about finding the constant difference is it verifies that this is indeed arithmetic. So how much did the student pay over the life of the loan? So if we were to add up all these terms plus all these terms in between, what's actually going to be paid? Okay. So it said we have a 100-month period, so we have 100 payments. So S sub 100, there's 100 payments that are going to be made, or 100 terms. So that's 100 divided by 2. I'm using this formula right here. I'm going to actually write down what formula I use each time so that if you go back and you're looking at this example, you know what formula was used. 100 divided by 2. The first term or first payment is 60. The last term or last payment is $40.20. So that's going to give me 50 times 100.20. I'll go ahead and put that in my calculator and I'll get an answer. And that's how much is going to be paid over the life of the loan. As you can see, you pay a lot more than $4,000. So you're going to put that in your calculator and get your total. All right, let's go to number 2. In training for a marathon, an athlete runs 7,500 meters on the first day, 8,000 meters on the second day, 8,500 meters on the third day, and each day thereafter runs 500 meters more than on the previous day. So the constant difference is plus 500. How far will the athlete have run in all at the end of 30 days? Okay, so we're going to do S sub 30. I don't know the last day, so I'm actually going to use this formula. S sub n equals n divided by 2. 2 times the first term plus n minus 1 times the constant difference. So S sub 30 days, that's going to be 30 divided by 2. 2 times the first term, so 2 times 7,500, plus n minus 1 would be 29, because 30 minus 1 is 29, times 500. So 30 divided by 2 is 15. This 7,500 times 2 is 15,000, plus, let's use my calculator and see what is 29 times 500, 14,500. So I get 15 times 29,500. When I add those up, multiply that, and I will get the total number of meters that the person ran in training for their marathon. Right. The next one. A woman is building a log playhouse for her children with the design shown here. There is no design shown here. How should she cut up a 10-foot log to get the 5 logs needed if each log is to be 8 inches longer than the one before it? Okay, so we're going to have 5 logs. So we're going to have an A sub 1, an A sub 2, an A sub 3, an A sub 4, and an A sub 5. The first log, we don't know what it is. The second log is going to be n plus 8. The third log is going to be n plus 16. The fourth log is going to be n plus 24. And the last log is going to be n plus 32. Right? And we will have to finish this problem on the next video.